So to summarize, we have three new functions that we define by applying derivatives in special ways to other functions. If we have a scalar valued function, we can create a vector field by taking its gradient. If we have a vector field, we can create a scalar valued function by finding its divergence, and if we have a vector field, we can find another vector field by finding its curl. Now to remember those procedures, we have this notation. We have this thing called the del operator, which is just a vector of operators. So, okay, and we can remember what the gradient is by just remembering that the gradient is del applied to a scalar valued function. If you have a scalar valued function, if you have a scalar and you multiply it by a vector, then you get another vector, and what happens is that you just apply those operations, the different operations, all to that same scalar valued function. So this is the definition of the gradient, but you can remember it using this del notation. So del f, you could just call that the gradient of f. Now for the divergence, you're taking that del operator, ddx, ddy, ddz, and you're dotting it with your vector valued function, which would have, in this case, 3 components. And what we get is, let's see, we get a scalar, right, when you dot vectors. So you're going to get the partial of m with respect to x plus the partial of n with respect to y plus the partial of p with respect to z. And finally, the del cross f helps you remember the curl. So if you do a cross product, remember you enter the component, you do ijk, and then you enter the components of the first vector, which in this case are operators, and then you enter the components of the second vector, which in this case are the component functions m, n, and p. And then this notation just reminds you of what the curl is. The first component of the curl is p sub y minus n sub z. The second component of the curl is m sub z minus p sub x. And the third component is k times, let's see, n sub x minus m sub y. N sub x minus m sub y. So we have these 3 different operations we can perform on either a scalar valued function or a vector field that produce a new kind of function, and we can remember what they are by using this del notation, which is just kind of writing the operations as a vector, and then these particular functions happen to have nice representations in terms of that operator.